Okay, what I had done is I have taken out the 4 screws that go into this aluminum corner pieces here, and I got the back loose, and the board is fastened to here. Now I had one hell of a time getting these 3 screws out, which were preventing me from pulling this out. And I had an awful hard time getting anything in there to keep the nut from rolling. I have to take out these 2. Everything is nutted and bolted. Nothing is self-tapping screws or anything. One of my viewers had a very good idea to put self-tapping screws back into here, and that's exactly what I'm going to do. I just have to find out what size, and I have to make sure they don't go into the circuit board. Oh, I have to remove this because it's held on by the deflection plate wires here, and there is like little coils here, and there are adjustments right here for them, and I have to remove that. I had an awful hard time getting that stud bolt. This is the screw that was down between the power transformer and the high voltage transformer. It's a number 1 Phillips, and it's right up against the body of the high voltage transformer. It was very hard to get a screwdriver in. And then they must have put some kind of a glue or something on all these nuts because they were very, very hard to get off. So now I got the thing released, and as you can see, it moves. But now I've got a lot of wires. Now I took a whole bunch of close-ups with the digital camera. I must have taken about 15 of them. So I'm not going to pull anything out of here until I get the capacitors and the diodes. Here is a better view of it. This is where the stud was, right here. It had a sleeve on it, a spacer sleeve, and a nut on top, which was a 1/4 inch. So now this whole thing probably can be removed, but I've got, well, this wiring harness here is just held in with like a piece of flexible flat wire. Best way I can describe it. It's almost like a bread tie, only much bigger and thicker. So they're not clamps. You just unhook these, and this can be freed off and be loose. But you've got wires that are like this, and this feels like solid wire, not stranded. I could be wrong. You got a wire here, you got a wire here, and you got a lot of wires that can break off on this. So I don't know if I'm going to be able to pull this far enough out. I mean, I can unhook this. I just got to reach in with a little screwdriver and lift the end up and just bend it over, and I can pull that out. But I'm not taking any more out now until I get the parts in. Now, these diodes here, I've ordered on eBay, and I'll show you on a screenshot. They're 1N5408s. I'm putting in 3 amp diodes. These top hats are probably less than maybe 500 mils, but I'm putting in 3 amp 1000 PIV, peak inverse voltage, diodes. Now, one of my viewers, and I want to thank him because I don't remember who it is, and I can't find the posting, gave me a link to Bama, and they have a schematic on this. It's not the exact model. This one starts out with OS, but the rest of the numbers are the same. The quality is horrible, and he even told me it was, but it's better than nothing. I printed it out last night, and I also printed out and enlarged 2 of the schematics, the CRT circuit and low voltage power supply. And it appears to be 12 diodes. There's 3 full wave bridge rectifiers, so that would mean 4 for each. That's 12 diodes. I only counted 8, but I could be wrong. I ordered 1N5408s from eBay, as I said. I think they're less than $2 for 10, if I'm not mistaken. I think I ordered 20, 2 packages, 2 packages of 10, so it's under $4. Now on the capacitors, these electrolytics down here, I looked all over eBay, and you cannot get an Axle lead 68. These are 60 microfarads. So 68 will work quite well, but I can only get radial leads. I cannot get Axle leads unless I want 350 to 450 volt capacitors, and they're going to be huge. They will not fit in there. According to the description on eBay, the ones that I ordered are 68 microfarad, 68 volts. And I think I ordered 10 of them, if I'm not mistaken. I'll show you the posting for the diodes that I'm going to be using and bought, and the capacitors. The capacitors are Illinois capacitor. Illinois capacitor, that's what it says. So it sounds like a good brand name. The diodes are 1N5408s, and they weren't very expensive at all. So if I can get that out, I'll replace them all. But what I started to say is the Axle lead, radial lead capacitors. I wish I could get Axle, but I can't. I can't deal with mouse or anything, or DigiKey. I just cannot. They nail you for shipping like you won't believe. eBay's my choice. I go to eBay. If they haven't got it there, I'll do without it, or make do with something else. If you stand the capacitor up, all right, this one happens to be just the, I didn't have a 68, so I had to tack this in when I was experimenting with getting the trace on the scope here. 68 at 350 volts. Now you can see that's quite large. That's probably about 1.25 inches long, maybe 1.5 inches. I would say more like 1.5 inches. The height of the capacitor, according to the eBay listing, is 11 millimeters high as it's standing up like this. Now, I'm going by my movie film days. 8 millimeter is about 1/4 inch. 8 millimeter movie film is 8 millimeters wide. So that's about 1/4 inch. So 11 would be just a hair over 1/4 inch. Maybe 3/8. So when they stand up in here, there's going to be enough room in there for all 5 of them little guys to stand up in there, and they won't come in contact with the power transformer. If, however, they are longer than what they claim, then I'll have to hunt around and try to get some Axle lead ones. The capacitors that are in here, as I said in my other videos, if you've been listening, is 60 microfarads at 50 volts. That's what's in here now. I'm replacing them with 68 microfarads at 68 volts. But like I say, they're radial leads, not Axle leads. I hope the leads are going to be long enough. See, these leads are long because this is a big capacitor. To reach from one side to the other. You can see where I cut them off over there. I don't like to have to add wire to it. It's sloppy. I do that with my hook and pinch method, but if I can get this board out and on the bench, I can do a lot neater job on it. Because when I pull this out, I don't want to have to take it out again. I'm checking all the resistors. There are some resistors on here, and every diode will get changed. I just hope I got enough diodes, and I'm pretty sure they're all the same. So it's a little overkill with 3 amp diodes, but they're going to be physically smaller than these top hats. Now, on this scope, there is only 2 fuses. And that's right here. When I looked on that schematic that one of my viewers sent a link to, Each one of these fuses is in one side of the line. One is on the neutral side, one is on the hot side. So there's a double fuse, but that's the only fuses in this whole scope that I know of, unless there's one in the high voltage transformer area, but I doubt it. So it's not like the Tektronix where you got about 6 or 7 fuses in the thing. This only uses 2. And they're right here. Now, when I had this on the Variac, I was drawing at 117 volts. I was drawing 400 mils, so it's a little less than a half ampere. Now, it might draw a little more when everything's working good. Now, being that this is solid state, it probably would draw probably under an amp. An amp would be about 100 watts. Just rough guessing. So, 400 mils is not bad, I don't think. Now, my intention also is to replace every cap in here, but only if I can get at it. Like there's 2 here. Like I say, these are the ones that felt like they were running warm, but it could be because the resistor's right next to it. But if I can get at the backside, which is way down in there, if I can't get at it, and they're pretty flush to the board, I may not be able to, or I could clip the leads and tack them on, and I hate doing that, but I've done it before. If I can't get at it something, I'll just tack it in. I really don't like working like that, but sometimes you have to. Now you can see these coils right here. I don't want to put a strain on them and knock wires off. Matter of fact, off camera, I'm going to take this right out now. I just don't want to take too much apart. I've got, here's the spacer for that stud there that was in the back of the board there. I don't want to take too much out. Now these here are the screws, and the nuts fell off inside. The screws that are impossible to get back in, so I'm going to use self-tapping screws on that. So it was a very good suggestion by one of my viewers, and I can't remember who it is, so thank you, whoever you are. I'm not sure if it was Carl or... I'm getting a lot of help and pointers on this, and I appreciate it because I've worked on scopes, as I mentioned in other videos, but only the real old ones, you know, with the 5-inch, like the ICO 425, I think, like that. I had a Hickok oscillograph 505 back in 1963. And I've worked on them. I replaced capacitors, but those things are a piece of cake to work on. They're very, very, very easy and simple to work on. Now, according to the book, this says 1969. According to the book that came off of Bama. So this is newer than I thought. I thought I had pegged this to be around 1960 or 61. Okay, so I'm going to remove that off camera so this don't get damaged. So I'll keep pulling on these wires here. You got wires that go down inside. Now my flashlight ain't working now. Here it is. It's for the deflection plate and some kind of adjustment there. So I want to release that because that's going to stay floating. Okay, before I go, you can see now I got a little more movement here. But I got to be very careful now because the more I move this, I'm going to be flexing these wires. And what I think I'm going to do is take these nuts and bolts and put them over here. I want to keep everything, you know, so I know where they go back, because these are going to go back in and these screws here are going to go back in. And the screws that I removed here, which I showed you in my hand over here, these things, are not going back in. There's going to be self-tapping screws. I just got to find out how big a hole is in these brackets here, and you can see how large that is. See how large that hole is there? So I might not be able to put a self-tapping screw in there, but I might be able to get that in because that's the fuse holder support. So I might be able to get that in there. This one here has got a smaller hole. See that down there? See that one right down, right where my thumb is? Right there? Right there. See it? I might be able to reach in there and do it, or maybe I can put a self-tapper in there. Because I need to support this. Because you got to push down hard to get these fuses out. So that's it. That's all she wrote right at the moment. I wasn't going to take this apart, but I'm going to leave it just like this so that when the capacitors come and the diodes come, we'll be in business. Illinois capacitors, even though I got them off of eBay and they look like off-brand, but it says Illinois capacitors, and you'll see that if I haven't already displayed that on the video here, the screenshot of the eBay seller. You see, I got wires that are. All right, that looks like a. That's just the coil. That's just a loop on the wire there. I got to be very careful with this, but it looks hopeful. It looks very hopeful. I'm being held back by wires in there. I'm good in this end. It's right here. But this turned out to be a little hairy, but a little better. And one of my viewers suggested maybe you can get the whole back off. That's what I was trying to do, but there's just so many things. See, like I hate to have things suspended like that. You know, it's too easy for things to get whacked, especially when I'm like a bull in a china shop sometimes. You know. This is it. That's it for part 3. When I get the parts in, and if those capacitors will fit in here okay, we will go with part 4. This is part 3 now. That concludes part 3. Take care, everybody. Don't do anything I wouldn't do, and if you do, do not name it after me. Thank you very much, and have a good day.